Hey guys, today's lesson is on identifying quadratic functions. In today's lesson, the student objectives: identify quadratic equations numerically, and use vertex form to find the vertex of a parabola. Use qualities of parabolas to find max or min, so maximums or minimums on the graph. Essential equations. What is the second difference test, and how is that going to help us? What is vertex form? And what are max and min? And below were the Common Core standards. First, we're going to talk about what's called the second difference test. Other than algebraically, so when you see like a quadratic expression, you can obviously identify that as a quadratic expression or a quadratic function. Well, sometimes you may have to identify functions based on a table of value. So if we look at this table of value, we can see that this is a linear equation. So I'm gonna write that up here: linear equation. How can I tell that it's a linear equation? Well, the first difference is constant. Now, you may have not called it the first difference when you were talking about linear equations, or just to refresh your memory, linear means straight or line-like. So a straight line is linear, so something that looks like that. You may have called that first difference the slope. Either way, it's the change in the y values, so this might look familiar. Change in y values, so say this, if this was y2 and this was y1, the change in those y values, 2 minus -2 is going to give me +4. Okay, and over the change in the x values. What's the change in the x value here? Well, -1 minus a -2 is going to give me +1. So y2 minus y1 over x2 minus x1. And this may look familiar. You probably saw this in every math class you've taken in high school. This is our slope. So our first difference is our slope, or our first slope, our first rate of change, our first difference. They are all interchangeable. So because this is constant, meaning it's going to go up the same amount and over the same amount between every point. Up the same amount and over the same amount between every point. It is always the same, so it is constant. So therefore, this is a linear equation. Okay, well, we're going to expand on that. If you notice the first difference, so y equals mx plus b, that's our linear equation in slope-intercept form. Notice the degree of x. I could just put a 1 there. We usually don't, but x is the same as writing x to the first power. So our degree of a linear equation is 1. That's how we know that the first difference, because of that 1, should be constant. If we expand that knowledge onto a quadratic equation, we're going to look at the second difference. Why? Because we have a quadratic equation, which means that the degree is 2. That's what quadratic means. Quadratic functions have degree of 2. So I'll write the rest of this out. So the same way I'm going to look at the first difference, I'm going to use the changes in y's. Okay, that's my first difference. And then, using these numbers, I'm going to take the difference again. So a second difference. Now, if it's a quadratic equation, the second difference should be constant. Oops, I forgot a couple letters there. So second difference should be constant if it's a quadratic function. So I get -14 when I subtract the 2 from 16. I get -14 when I subtract, -2 from 2. And it's important when you're doing this, just a side note, that if you're taking the bottom number and subtracting the top number, so 2 minus 16. You must do that for every difference you take. Okay, so it's constant. So 4 minus negative 2, 20 minus 4, 46 minus 20. Okay? You could do it the opposite way, but you would have to do that for every single step. You can't switch it up in between, or else you'll get the wrong numbers. So my suggestion is just to go top to bottom, or sorry, bottom to top, the way that this example shows. And then I'm going to take those numbers that I got. So 26 minus 16, that gives me 10. 16 minus 6, well, that gives me 10. 6 minus a negative 4, so it's really 6 plus 4. Oh, wow. That gives me 10. 4 minus a negative 14, so it's really 4 plus 14. Wow, that gives me a positive 10. Since all of these are constant, then yes, this is a quadratic function. Next, we're going to talk about the vertex form. Vertex form is a way to show us the vertex in the equation. Just like we had vertex point slope form for linear equation, this is kind of like that same type of thing, except for the one specific point it's showing is the vertex. When talk about the vertex, you may see problems label it H and K. Now this is just specific numbers for the vertex. So when you see that, think vertex. H is really just the x value of the vertex, and K is the y value of the vertex. Okay? So if we go up here, H is the positive y value. Something to keep in mind, it is being subtracted in the vertex form. So if I have a positive H, okay, in my vertex, I will write it in vertex form as x minus that positive H. Okay? I just put a plus there and put in parentheses. If I have a negative H, in my vertex form, I'm writing that as x minus a negative H. So, really, you may see it in the form of x plus h. If you ever see x plus h, you should know that the h value in the vertex is negative. Okay, and then moving on, k is on the outside of the parentheses. It's at the very end of the equation, and if k is positive in the equation, it's positive in the vertex, and if it's negative in the equation, it's negative in the vertex. And last but not least, we're going to talk about maximum and minimum. So there on the graphs, since the parabola is either going to go up and stop and then come back down, or it's going to go down and stop and come back up, that leaves us with a maximum value or a minimum value. And as you can see, I just wrote there, first we have to determine which way it opens. So if it opens up, or sorry, if it opens down, like I drew up here first, then there is a maximum point. And when we're talking about the maximum, we're talking about the function's value. So what does y equal? So as x gets bigger, so as we're going from left to right, so x value is getting bigger and bigger and bigger because I'm going from lower values over here to higher values over here. My y values are getting bigger and then higher and then higher and then higher, and then they're going to stop getting higher, and then they're going to start decreasing. My y values are. Alright, so that's what that means. So there is a maximum y value. Max y value. And it's the opposite here as my x's get bigger. So as I go from left to right, my y values get smaller and smaller and smaller and smaller until a certain point. Then at that point, my y values are going to start increasing again. So there is a minimum. So if it opens down, there is a minimum y value. Okay, and coincidentally, that point where it starts to turn, or where there's a minimum or a maximum value, that point is called our vertex. Here's just a little more explanation of it. When looking at the standard form, if A is positive, then the parabola opens down. Opens up. If A is I thought I said something wrong there. If A is greater than 0, so if A is positive, then it will open up, and there will be a minimum. If A is negative, then the parabola opens down, and there will be a maximum. So if it opens down, maximum value, and if it opens up, minimum value at your vertex. That's all for this lesson. Hope you enjoyed yourself. Hope you learned some things. Be sure to try your homework assignment. If you have any problems or questions, make sure you go back through the video. Take some good notes. Really try to understand something. If you don't understand something, go back through it. The more you watch it, the more you'll pick up on things. The more you practice problems, the more you'll pick up on things. And then as a last resort, if you don't have any questions, of course you can always contact me. Whatever is easiest for you. Feel free to contact me on BBIM, text message, email, and be sure to come to live class where we can go through this a little more.